Okay. Hi everyone, my name is Mutahar. I will be doing this final presentation. This is Group C. Other member is Error. So this is a feature-based modeler for Android. These are the contents which I'm going to follow throughout the presentation. I will start with a review of previous goals. What was the main problem? I will do some comparison of the existing apps. Then what method we used to reach the goal and what issues faced during that, and then the scenario demonstration video, and then I will propose what can be the future direction. So let's start with the review. So previous comments coming from the previous presentation, midterm presentation. So we were asked to add the implementation details, and we added the scenario as well, and professor said that it will be nice to have the motion based camera control. For the previous schedule, it's the original schedule. We are now in the week 16 and I am presenting pretty much it's the same. For the problem, our main goal was doing 3D modeling on smartphone. So the motivation behind this goal was actually flexibility in design, as Professor Hyungi in his lecture told us that we can do on-site inspection, we can review, we can modify while we are traveling. Second thing is the smartphone oriented, because current phones are heavy, they require more processing memory, they require more space. Then there is connectivity, you can be anywhere. You have the mobile all the time, sorry. Then you have the computing power, you have the low computing, you can 3D model even with the low computing model, and then you can model and use the sensors in the mobile, and at the end it's the recent trend. So we set the desired functions, like for the 3D modeling we should be able to view, should be able to sketch, model, modify and delete. Next, moving on the comparison, I did some comparison on existing apps. I think other groups all discuss apps. So we have Shaper 3D, we have Forger, we have STF, and they are apps. Some also works on the Windows platform. So our work is at the end. Next is the...
What is the meaning of blue, green and red? Circle.
Green?
Green circle and red circle.
Green is yes.
And red is no.
Yes. Red is danger, like the traffic signal. Okay, I will move on to the method. So we have different options when we are going to build the 3D CAD app. We can use the geometric modeling kernels presented by the TA, but we choose Unity because our target system is Android. We need touch, we want the output in the APK file. So one of the main thing about Unity is that it has multi-platform release, and also the other things about the Unity is that it has mesh based modeling, and the data structure is triangular mesh data structure, and there is a lot of online support. Coming to the original development plan, so we made the mind like we should have the CAD-like UI, we should have standard sketches, then 3D, and then at the end we should have the in the iPad or in the phone. So implementation specification for the implementation Windows 10 64-bit. We had the Unity latest, not latest, but it's 2018. So we had the integrated development environment as Visual Studio 2017. Language was C Sharp, and target system was Android among the smartphones. And testing tool is Unity Remote 5. I will show later, and version control tool is GitHub. So on the in the method I will show the progress so far. So for the planes we implemented standard planes X, Y, ZX. For the plane selection we allow the user to select from both sides. For the plane highlight when it's selected, menus we have sketch, we have feature, we have decimal input, and we added the additional delete as well as minimize, maximize. Continuing the progress on UI, I have in the selection, I just told you that we can select the plane from both sides. You have to make this function because it's not inside the Unity. We made bigger button because it's easy to select in the smartphone, and we also implemented the face selection, which works by making a plane on the face that is selected, and it is only during the duration when we sketch. When we sketch is complete, this plane disappears. Progress on 2D sketches, up to the midterm we had circle, we had rectangle, so we decided to do the polygon. So we have the also now polygon available. You can put the radius and you can put the number of sides depending on the same mathematics. So you will get different number of sides. In the meshing technique is the same as we presented in the midterm. We extract the, depending on the profile, we extract the control points, and they are different depending on what you are going to mesh. Because in the triangular, if you don't take this into account, then you may not get very refined shape. So proper point is important. In the progress now, I have 3D features. We were successful in implementing, after implementing extrude, we implemented cut extrude or pocket or hole. So as you can see, this is from the output. So these are the different things we can do. There are some other models that I made with the app that we developed. So because with the cut extrude combined with the extrude, there is a possibility of making different models. Okay, let me show you the video for this scenario. I will later on do it on the mobile. I will try to. Okay, this was what we added in the previous presentation we were asked to. So coming to the issues, there were a lot of issues. The main point is that Unity is a game engine, so it means that it's not exactly, the functionality is not with respect to the 3D modeling. So you have to make a lot of tuning, you have to do the additional steps to reach the goals which are needed in the 3D modeler. So in the plane we had just one-sided plane. For the phase distinction, we had to made a new plane on the position of the selected face. For the cut extrude, we use the boolean as given, idea was given from another group. The camera touch, because to optimize the speed at which the cameras should move with the finger movement or the other, I think that required a lot of tuning as well. So next is the sharing. So I just showed you this scenario, and this is the Unity remote. I will try to do it with the app. So actually this is how we control the touch. Okay, it's visible like this. I will optimize the window so that it's available like this. Then like this. For the keyboard, I will be using the desktop's keyboard. 2.5, let's say. Okay. So in the 3D button, I have extrude, so it's extruded. Now let me go on the other side. I have sketch. Let me do this. I think I selected other plane, I think, so I will go back.
Is that the same as smartphone window?
Yeah, we are, this portion is smartphone window, this one.
Okay, same as
Yeah.
You're using smartphone only for user interface, right?
Everything.
I don't think so, because the memory input is from your laptop.
Yeah, but
Yeah, the APK file. You
You
mean?
should try it from APK file.
Yes, we can do that.
we have it.
But
You should try it from.
yeah,
Yeah.
you can see
we
the Alex.
have it working on the APK file, but we have a texture problem because we use a custom shader, and that's why we do this Unity remote.
Yeah, that's.
But it's the same working principle.
Point is that there are some differences with respect to the
Power and
meshing problem of Unity.
yeah, you're right.
So in this way you will be meeting those.
Yes. So
It's but
yeah.
yeah.
Okay, it's a bug. So
Just show the
Yeah.
camera.
professor said that do the accelerometer. So we can,
Good.
I can, for the selection, if I do that, I will change. So this is, I think, do you want to try
On
the demonstration?
on-
Okay, okay. So that's the demonstration, and what is the future? So with the cut extrude and extrude done, we propose that there should be a standard set of features, and I found out tutorials about the Bezier curves. So these curves help you make the surfaces which we studied in the theory of chapter 2. So that is possible with the Unity, and at the end the control can be refined, and we can add voice recognition or history record for the feature tree. So reaching to the references, these are some links and related articles which you can have if you want to develop more related applications. Okay, that's all. Questions?
Very different.
It's old.
When you cut a strip, is the mesh generated inside the?
Yeah, the mesh is there.
I didn't see it in the video.
The that is refined. It looks like refined.
What about the inside of the
That is,
surface? Yeah, but the
yeah, there is mesh. Actually, Tahir's idea, the Boolean, we kind of use that.
About the polygons, can the number of sides be modified?
Yes, we modified in the video. Did you saw the video? We modified in the video.
Show us. Okay. Show us.
Actually, why not use the desktop?
Oh,
Yeah.
one more question.
Yes.
Can the polygon be used for cut extrude?
Yes. So kind of, if this is the polygon, we make it. So it's asking the radius. Let's this and the sides like 9, 4.
Can we add two?
We have a line. You
didn't.
have a line.
Oh, stable. Yeah.
So it's compressing the radius.
I think my point is that we should limit the user consent.
Yeah.
Please go ahead.
Okay.
Have you guys utilized the mobile's keyboard?
Yes,
Yes.
Alex has that.
Can show that.
APK file has, but the texture issue limited us to demonstrate the APK. But we have the APKs.
We also did the APK. We did the face issue like.
The issue we face.
Because we have face selection and
Face selection.
it's very complex.
Okay.
Yeah, to change the color of some triangles of a face. We can't use that with default shaders of Unity, so we have to use a custom shader, and it doesn't work with mobile.
Like what was your target APK environment? Like which version of the Android is the base?
12.
Which Android version is the base? Like this will work on this and not lower than this. Like my phone is 8.0, my other phone is 7.0.
8, it was 8, the version which we did, Android.
Works with any.
It will not.
It will not. I saw a tutorial. They said it will not work.
That is the set in the Unity and download the SDK.
Yeah.
Your smartphone can use that.
Yeah, right. Unity remote.
I'm just asking their target, like over my 7.0.
Actually, we followed our version.
So what is your version?
Okay, I think
Mine is 8.
8.
Mine is 8. I don't know.
Let's go with 8. Because he has the APK, right?
Okay, I will bring my 7.0. It will not work on it.
Yes, I faced the issue during.
Another question.
Okay, yeah. And the question is, you use the mesh in circle. You
Yeah.
use the 32
Yeah.
in the circle.
Yes.
So is there any reason why you choose 32?
We can increase. There is no specific
It's
reason.
just like the minimum amount of
Yeah.
sides for which it looks like a circle. So
Because the triangle are on the surfaces,
Yeah.
so it looked nice with the 32, so we ended with it.
Your choice is some reason over the
Yeah.
shape and the calculation.
Yeah.
And so your team can select the face in the feature.
Yes.
So how to select the face? For example, the shutter lane.
Yes. Ray.
Use the shutter lane.
Yeah. And that location we make a new plane, an instance of the plane that will be removed when we end the sketch.
Then how to determine the base plane and the face of feature? I mean, you draw the sketch on the XY plane
Yes.
and extrude the sketch.
Ahead of the XY plane.
Yeah, then the first face is on the XY plane.
Yes.
Then how to determine if this is XY or the face of extrude?
I couldn't understand your question.
I mean, this is XY plane.
Okay.
So draw the sketch
Okay.
and extrude. So the one of face of extrude located in XY plane.
So we don't select that face.
Only select the face.
Yes.
And this is comment. So your team, everything also uploaded in GitHub.
Yes.
So please write some description how to set your software and how to build like this, because the other guy see your code and they want to use your code.
Okay.
Yeah. So description and in the issue, the slide.
Sure.
So you mentioned one cut extrude.
Yeah.
Its idea is based on Boolean operation. So why that is issue? At that time, that item is.
We had the issue. We took the idea of Tahir.
Mm,
When we started, like you may ask other group, like they will be facing some issues regarding cut extrude.
Boolean operation is. Understand. Okay, that's all.
Thank you.
How do you determine the direction of the extrusion if you select face?
The material addition, which side it will be, right?
I mean, yeah, the direction. I mean, if you
The
select
normal.
face, it could go.
Not normal, but it can go there or there. So there is minus in the keyboard, like minus plus, minus 6 or 6.
And what about if you select one of the faces of the circle and the normal will not be parallel to any of the.
You can try that.
Basically, a circle, because it's many sides, you have many small planes, and you can draw on the small plane. You're not supposed to, but you know.
That's great. Even with the polygon.
Nobody can determine to use the right hand side direction to the start point. The rectangle or circle or polygon is draw the one point to the other point. So draw and determine the direction of the two main lines. Then you can select, choose the normal direction.
Thank you.
Right. Here. So, do you suggest we need to replace Unity next time?
With some geometric modeling kernel?
I don't know.
I think
I
geometric modeling kernel is better.
But it can be too heavy. That's why Inamdi proposed to use this one, right?
Yes,
But you are not satisfied with this.
because I first learned ACES. In ACES, everything is defined.
Right? That is big one. Luxury, right?
Yeah.
This is light.
Yes. So for limited functionality, we can go with Unity. If we want to make professional or technical application, then we should
So
use.
smartphone is limited.
Yes.
So what is your suggestion? Okay, anyway. So please summarize your suggestions well to your report so that next year followers can work
Okay.
instead of me, right? And how about importing models?
I think that's possible, but we did not try that.
It's not so difficult.
Okay.
No, I'm asking.
Uh,
Importing meshes.
Importing.
Existing meshes.
I think the existing meshes can be imported because the one of the references which I quoted here, editing 3D models on smartphone devices. This paper is exporting.
Exporting, not importing.
I think I
Anyway, okay.
think
And then another final question is, how about photo-based modeling?
take a photo with mobile and
Take picture.
Professor, this in my comparison table, this is this allows Shaper 3D allows this.
Shape 3D. Shape 3D.
Shaper 3D allows capturing and
Right down there.
okay,
Right, thank you.
okay, thank you.
Q&A.
Good afternoon, everyone. This is the final exam of A team. My name is Hyebin Kim, and my partner is Fahim. The presentation contains introduction and system structure and app functions, and conclusion and differences. First, the purpose of TON project is making a geometric modeling tool as smartphone app, so it should perform geometric modeling work in smartphone environment. So this is our method. Using Unity and C# script, we make a mesh generation and geometry modeling, and finally we make a APK output. And this is the whole diagram. This is the diagram of whole system. So the order is sketchy and creating feature, and additional functions are view transform and unique form features. This is our scenario. This scenario is includes extrusion, cut extrusion, and sweep, but there was a difficulty of implementing all of them, so we reduced the target feature. So this is the final target features. So in Sketchy, there are rectangle and ellipse, and in solid feature, there are extrude and cut extrude. Then this is our job allocations, and this is our schedule, final schedule. And I will explain the system structure. To make sketchy and solid feature, we design data structure. So there are plane, and line means sketchy and solid. So they have many components, and we put the information to the structure. And we use the mode changing. So there are 4 modes: main mode, select mode, sketch mode, and solid mode. So main mode provides camera view and gyro mode, and select mode can be used to select sketch and solid and face. And in sketch mode, we can draw rectangle and ellipse, and in solid mode there are extrusion and cut extrusion. And this is our main UI of application. So using button, we can approach the many modes. So, and this is sketch mode button and solid mode button, and this is gyro mode button. And we also use touch event for gesture. So we only use single touch and double touch, and there are the types of touch gesture. First, I will show sketch mode. The order is plane selection and sketch feature and sketching. First, we select the plane using the UI. So XY plane, YZ plane, GX plane. So we can select the plane, and then to the sketching mode, we can select the sketch feature. And then using the single sweep, we can draw the sketch. And this is the select mode. So if there are sketchy or solid or face, we can select the features. So this is the using the single touch down, we can select the sketchy, and also you can select the solid. And when we select the solid, we can select the face of that. So visualization is not good, but face selection is working. And then after face selection, we can sketch on the face. So this is the order. So after making extrusion, we select the face, and in the face we can sketch the rectangular feature, and this is the result. And this is the solid mode. After sketching, we can make extrusion in the mode, and then using the double sweep, we can changing the length. So the length is yellow text, so it is working like that. And these are additional functions. First is camera view. Using the single sweep and spread pinch, we implemented panning and zooming of camera view. So this is panning, and this is the zooming. And in our last presentation, Professor mentioned that it would be cool if we could change the camera just by shifting the orientation of the mobile. So we implemented that function in our gyro mode, so which utilizes the mobile phone's built-in gyroscope. The gyroscope works by using inertial force. It is different from Utara's team math, but it working. It's like a AR mode. and using acceleration sensor, we implement. We can detect the shaking of smartphone. So using the function, we can erasing the sketch in sketch mode. So it's a short video, so we can erase the sketch.
Which one is disappearing?
Yeah?
That's the, which one is disappearing?
If there are
Which one is erasing?
multiple sketches, all the skin are
No. In the sketch mode, it's only
Active mode.
The active sketch.
yeah active
Active
sketch.
sketch.
Yeah. So and it's our conclusion. The summary is we implemented sketch and solid feature for rectangular left exclusion, but cut exclusion is not yet done. We actually implemented the plane selection, but we couldn't implement that. And using various gesture, we like single and double touch event, we can implement camera view and sketchy functions. And we did implementation for additional function using smart program function, using gyroscopic sensor and accelerometer. And these are our references. Thank you. Any questions? Yes.
Do you select the face by touch
Yeah. No, by touch.
or just move through all the faces?
All the faces are stored in a list, and just by touching the button screen, yeah, it goes through them.
And did you test it separately on your phone?
Yes. Its video is
All the videos
set.
are
Just this is a power cable.
for the plane. Okay.
Yes.
When you sketch on new code, on new objects,
Sketch on face?
Sketch any selected face.
Any select face? Yes.
For the plane button, plane X, Y, plane Y.
Yes.
So when you use that button, is it the current view? I mean the plane that is activated, is
Yeah.
it the current view, or you can move and you can select the other side as well?
We can view the other plane like that.
So initially, if you sketch, it goes to that plane, but you can pan out or zoom out.
No, I mean that you have a very ISO view,
Yeah.
your planes.
Yeah.
So if you select button XY,
Yeah.
so the XY is activated. Which
Yeah.
side is activated?
You mean like which direction?
Yes, if you want to
It's
go on the other side.
Other side?
YZ or GX?
This plane has two sides. So
Ah.
you can sketch from here and here as well, or just the one which is in the middle.
We choose the normal like XY plane is right hands.
Okay, one side.
So, the recent presentation, your team said we tend to extrude, evolve, and sweep.
Yeah.
The other friends, evolve and sweep.
Under construction.
Under construction. We don't have time.
Your team showed the select the face
Yes.
using touch. And then the cut extrude, the process is very similar to extrude.
Yes.
So you have enough time or some other reason?
Not enough time.
You can extrude by acceleration.
The last question is, your team is the face selection is just touch. Then if the solid model is are two or more,
Yes.
then a lot of faces in your scene.
But first we select the solid model, and then we select face for that model.
Yes. Face selection is active after solid selection.
This only has 99 pixels. And you want to select the 99
I think the acceleration grading is good idea because in iPhone also the acceleration used lead the word same as to your goal. Okay.
You copied the idea.
Copy the idea.
Thank you.
Why don't you show us a live demo?
Like I can do that.
Right. Show
What?
us. There was a question.
I cannot.
Sketch on a select plane.
Here?
Yeah.
About what?
Sketch on a select plane.
Okay. I select the plane and go to sketch, and I can make a sketch. So, and there are many, yes, any sketches I can make, and I select the sketch and extrusion.
Oh, it's
So-
really okay.
Yeah, and cut. Yeah, and
Why direction is different? You pull that direction is, I think it seems like
Opposite.
opposite is the orchid. I don't know. So and and
Question was, if you have a
face
cube,
cube. Yeah,
make a cube first,
yeah.
and then select one of the face of the cube,
Ah,
and then sketch on that face.
okay. And sketch select create 아니 이거를
Erase.
and extrusion and face selection and
Side one.
can
Is it true?
yes
Where is the true?
uh
Oh, show me. Show us. Show us the true.
here
Okay. Select the side face.
yes select
Deselect the top.
But side face.
side face I can do that but only two face I can see but I
Only
can
top and bottom is big cover.
no 그
Before
yeah viewpoint is the view I can see only I see
I can see only three faces.
yeah
Or
but
two, right?
six face is can be selected
But
but we didn't see that we cannot see that
We can see three faces.
three
Two,
face
Right?
and okay I select the face
The side face.
yeah 아이고 moving
One of the side face.
네?
There are four side faces, right?
yes
Top, bottom,
yeah
side faces. Can you select one side, one of the side,
yeah
and then sketch on there?
ask yes
Show us. Show us.
I select here
Okay.
and sketch sketch that we didn't see that but we rotation we can rotate the
Okay.
it's not complete
Alright. Thank you very much.
thank you for listening.
Good afternoon, everyone. So everyone seems to have a well-functioning application ready. So I will be representing myself and Tahir for Team B. And here are the contents that I will be presenting. To briefly review on the goal, for our initial primary goal is that we need to create maybe 2D sketches, and then we create a 3D solid from these sketches, and then maybe integrate different shapes for these functionalities. And for our secondary goal, we wanted to implement camera movements and allow some degree of modifications to these solids, such as maybe removing material or sweeping. And this is the comparison of our intended goal with other applications existing on the market. So this is the method that we will be using. Our development environment is Unity version 2018.2.7. Unity, as said before by the previous team, is a game engine. However, it also allows us to create Android apps or iPhone apps. And it also actually has a collaborative function where we can, the project is integrated to the cloud and teams can work together on the same file. Then our target environment is for Android version 7. Generally, a high memory is recommended, but I will explain later. But for one of our applications, it's actually not quite memory intensive. And for more details, Unity uses a mesh-based solid model. So to create the models, we have to define these triangular meshes. And then we can use C# scripts for determining the environment, property, or parameter definitions for our shapes. And since our target device is mobile phone, we need to utilize the advantages that they give, such as their input touches. So we came up with two methods. The first one is a sketch-based method. In this one, the inputs of mobile devices is much more emphasized. However, it is less accurate, but we trade the accuracy for more intuitiveness. Personally, I find that in some apps, if you want to type in a value, the keyboard pops up and it fills more than half of your screen, and I find it annoying. However, we also have that option for our second method, which is the primitive-based approach. We can use predefined solids, then use some CSG techniques to the solids. Then it also allows us to input values for more accurate results. So first, I will be explaining about the sketch-based result. Basically, as I said before, it utilizes the touch interface of the mobile devices to sketch predefined shapes. So the main features that it has is that it has three shapes. We can make three shapes: rectangle, circle, and triangle. Then allow the extrusion of these three shape sketches. And then it also allows us to adjust its position using transformations, and allows the design of mobile UI and camera movement. So how the sketches are made using these methods, the important dimensions are shown on the screen. For the rectangle, you swipe from the top left corner to the bottom right corner, and for the circle and triangle, it's similar. You start it from the center and move to one of the corners or the edges. And for the extrusion, previously this app was designed so that you can extrude while putting your finger on the solid itself. However, it brought us too many errors. There was too many problems with that feature, and I spent countless nights to solve it, but it was, I think, unsuccessful. So I changed it to a slider-based function. But you might ask, why slider? Because this is extrusion and slider will give limits. But I find that I want to emphasize a mobile input, and slider is better than inputting values. And it's also smoother than using buttons. And, well, it also has less errors. And during the extrusion process, we can move the model in the 6 dimensions. So this allows us for some degree of customizability. And for the user interface, it's primarily designed for mobile phones. So the user interface is put on the sides of the screen, so you can have as much space to view the model as possible. And then we also designed it so that it must work on multiple screen resolutions. So that is done by setting the scaling or the screen anchors for these interfaces. Then the interface mainly consists of buttons and sliders, and also some parameter information. The camera, 2 cameras are used for this method. The first one uses an orthographic camera, which is integrated during the sketching mode. And with the orthographic camera, we don't have to see any perspectives. Then the second one is the actual 3D camera, so that you can see the 3D model. And some gestures are implemented to control these cameras, as you can see. So the main procedure when using this method is that we will just first enter the sketch mode, select a sketch, and then extrude the sketch and change its position if we need it to, and then just press confirm. Basically, the integration can be summarized in this flowchart. For the first step, you can have any shape definitions that you want. However, we only put 3. But because of the structure of the script, you can put any definitions, and you can just transfer that definition to the extrusion script, and it will extrude them. So when I first started the project, I used a lot of scripts to create a basic function. And this thing is finally solved with only 4 scripts, which is why I find it to be not memory intensive. And only 2 of those scripts actually required for feature definitions. And for our second method, which is the primitives-based approach, we use the same Android development and targeted device specifications. However, the approach for this one is that we use predefined solids, and the C# script is needed to create the predefined primitives and to update these primitives, as well as to perform some CSG operations such as subtracting the model. And with this one, the unity is positioned in the sides as well, similar to the previous one. And you will have the coordinate information. These are all values which you can input with your mobile keyboard. Firstly is the coordinate information of where you want the solid to be, then some orientation for its rotational information, and this will be where the features names will be listed. And these are the options. These are unity primitives: rectangle, cylinder, capsule, and sphere. And this one is ProBuilder based primitive, which is another, it's not another application, it's an add-on, asset add-on for Unity that we utilized. And that one is where we define the dimensions, and we will just press these buttons to update or delete. Then the information regarding your solid model will be displayed in that position where primitive 1 and primitive 2 is. And then you can further edit them using those 3 buttons using a CSG method. Here are the predefined solids, predefined primitives that we have. And these are the ProBuilder primitives. So the steps to use this is that we first select primitive to update or delete. Then the primitive name will be shown, and the values can then be changed with the dimensions and coordinates and the rotations. Then we just click update or delete and to create or remove the solids. So this is just if we want to further edit the solid, we select the 2 different primitives first, then the primitive name will be shown, which the ones that you selected, and then you can then start your CSG operation to subtract or reverse subtract the solids. Here's a video demonstrating this function. For this application, it's requiring a high memory, and you can see why, because it kind of crashes due to the low memory. So you can remove the solid using this operation. So with our 2 operations, we decided on a scenario. On the previous presentation, our scenario was an L block, but maybe that was too simple, so we decided on some tables or chairs. And with the sketch-based approach, these are the models that we managed to create, and this is the model that the primitive-based approach created. As you can see, it's the model is somewhat resembles the target scenario. However, with that method, it's less accurate, and this method, it's more accurate, but then it's much easier to perform using that method. So here's a video demonstration. This is done on the mobile. Maybe at first we thought to be it is ambitious to create a simple car, but this is how a car can be made using the sketch-based method. So take a while. So now to make the tires, select a circle, then place where the circle wants to, where we want to place the circle. So I have to mention that the camera only works when you're not editing, so we can't really control the camera at this stage. Then if I fast forward, so if you really take your time and be as careful as possible, you can create a simple model of using these three shapes. And that is a car. Then for our second method, we input the values, the dimensions that we want. This is in the Unity environment, but I will show you in the mobile environment later. So the rectangle names will be listed here. Then you can input the coordinates. So for our third model, we have a cylinder, and now we want to use the CSG operation to remove the cylinder from the solid. And next is on the mobile environment. We use the mobile keypad. And perform the CSG operation on the smaller rectangle. Reverse subtract to remove it from the solid model. And now I will show you a live demo of our application. First one is the sketch-based method. I will maybe create a simple table. So just create sketch, rectangle. I created a rectangle there. I'm not sure if you can see it.
No.
No? Okay.
Right top.
Never mind. I'll just extrude and.
Can you click right there?
Okay. And confirm, and you can see. Let me just zoom out. There is a rectangle there. The camera is a bit wonky. Then I can sketch again. This time a circle for the top of the table. Click extrude. Then move this up. Click confirm. And now I have a kind of like a table. Okay. And for our second method, one second. So I input some values, maybe 100. And the rectangle is created after I input the values. And then I can add more. Okay, I think I made a mistake. The second rectangle is not created.
Check the means.
Oh, there's actually 3 rectangles.
Yeah.
Anyways, right. Yeah, so that's the feature-based, primitive-based method. Wait, so these are our job allocations.
Oh, okay.
Sorry. These were our schedule. And for final remarks, well, Unity, as I said before, is a mesh-based operation to create solid models. So we need to work using meshes. And for our applications, I think the primary goal is achieved, but due to the complexity needed, not all of the secondary goals are achieved. We can somehow modify it, but not to the extremes that we want. However, yeah, shapes can be used and modified, can be created and modified using the 2 methods. And here are references. Thank you. Yes.
So for the sketch method, you can only sketch on one plane and extrude on one direction.
Yeah.
For the sketch, can you do the cut sweep?
No.
So I don't get the idea that you are putting the exact position, but you're saying that it's less accurate.
You put the exact positions, but you can't. It's less accurate because, for example, it can show you. So it can show you the dimensions, but you can't control the dimensions. That's why it's less accurate. So I'm going to be doing it really slowly. You can.
So to overcome that, you use primitive?
Yeah, so a different method is primitive, using values, but not.
Primitive is overcoming this.
Because then you can input values instead of using just mobile touch.
The primitives are mesh-based.
Yeah, they're all mesh-based.
And they are defined previously in the Unity.
Yeah.
But how is it better to use the pre-made primitives because they limit you in comparison with the commercial CAD systems?
Mm-hmm.
So you are using the primitives that are mesh-based. So when you will go with the CSC, there will be complexities of the meshes.
Well, yes, you're right, but the mesh-based is in both cases. Either you use sketch-based method or you use the other method that is primitive. But in the case of primitive-based method, when you define a rectangle, there are only 2 triangles on its face. So in the case of primitive-based method, I think that some primitives are less memorable, but the primitive-based method has some positive, like you can define primitives like sphere and capsule.
But those can be made in
Sphere?
Sketch. How?
For the sphere?
Yeah,
For the sphere,
yeah.
you make a half circle and you
Yeah.
revolve it.
So did you implement it?
No, I am talking about the why you selected different ways.
Huh?
You are saying it makes capsule.
Capsule, sphere, and other shapes like rectangle. Actually, you can use cylinder. You use circle and rectangle to make the sketch and then extrude, right? The same thing can be made with cylinder and rectangle.
Very specific application. Like cylinder and sphere.
Yeah, so actually sketch is useful when you can input the points like aerofoil and then you can extrude that aerofoil for some purpose. If you are using the sketch for simple cases, I didn't think it would be a good idea to implement the sketch for trivial applications.
Okay. A funny question. Can we make fighter jet?
Sorry?
Because you made the truck. So
Yeah.
can we make more complex application?
If you have time. What do you want? Fighter jet?
Just
Fighter jet?
airplane.
For example, I can use two triangles for a right-angled
Which
wing.
will you use, the sketch one or the primitive one? This is the question.
I might be biased, but I'll use the sketch-based one.
Sketch based.
Yeah.
Because it's less accurate. So
Yes, but it gets to look like a jet plane. I mean, you can maybe use this for simple simulations, like where you don't need accurate models, like VREP, for example. You can just use like the car model to maybe use that as the car.
nice.
So you guys made like two different methods, right?
Yeah.
But if say I want to compare models from the two, can you export model from one to the other?
No, because our plan was to combine them, but we didn't have enough time to combine, so that is why we picked them.
Okay. Okay. In page 6, this question is similar to the team said the primitive-based approach is more accurate, and sketch-based approach is less accurate. But as you know, in CSD method, just use predefined primitives, cube, cylinder, cone, cross, like this. So that means in CSD method, the result of CSD method is unlimited. So basically, in CAD, the purpose of CAD is draw the model more realistic. So actually, in my opinion, I didn't agree about that word.
More accurate.
And so I think your team is more focused on the CSD method than feature-based modeling. So why your team more focused on the CSD based on that theory?
But we'll use CSD on one method.
Actually, we could not use complex shapes to do the sketch, right? Actually, we are using simple shapes and then sketching.
But that is the problem of in your your teams. But generally speaking, sketch base is more than
General.
making complex models. And many of commercial cases use sketch base. Why? Because sketch base the modeling is more than use gesturized.
So when I want to compare between the less accurate and more accurate, with the sketch base, since you're mainly using mobile inputs, that's where the loss in accuracy comes from. And however, when you compare it with the other method, which is primitive will be more accurate.
But in past years ago, we can say that. But currently, the on-shape is released. On-shape is made model accurately, more accurate in PC, web, mobile device. So now we cannot do that sentence in mobile field.
But on-chip is like cloud-based.
Yeah, so side.
Yeah. So whole computing is not done on the mobile. Yeah. That may be the
That is
reason.
different. Our home project, because our home project is limited to people, limited budget, and devices.
Give us more than one semester.
Yeah, okay. That's all. Thank you.
See, mesh, the sketch based is less accurate, but it's quicker, right?
It's quicker,
And
and
then you can edit with numbers. Then it can be accurate, right?
yeah, that was our
You
plan
are
at
saying
first.
accurate because you can input numbers.
Yeah,
So after quicker rough sketch, and then you can modify using numbers. Then it can be faster and accurate.
yeah. That was mainly. Yeah.
One question. In general, you are saying Unity is based on mesh, but how do you use primitive? You enter only 3 numbers for cube, right?
Yeah, and those 3 values is the only one you need to define a 3D cube mesh.
And the data structure is primitive, is CSG, rather than mesh. So mesh is used only for display. Is it right?
Actually,
So in the case of GDI, predefined models is also a mesh.
So it displays a mesh, not stored as a mesh. Storage is only 3 numbers, right? So this is not, you can say, solid-based.
Professor, maybe initially, because we input 3 values, but we also first determine the initial position. So with all that information, that's where vector positions come in. So we will get 3D vector position information, and that's how they define the meshes in Unity.
So for the display. So can you modify the number after creating?
For this
The internal data structure is only 3 numbers. You can say this is so, right?
Yes.
Primitive.
Yes.
for our,
Much more than you cannot modify
for our application, it's modified by changing the positions of the vertices.
not by parameters.
The parameters will be translated to vertices vector information
Right. For the
using the
display,
script.
right.
Yeah.
Internal storage should be the parameters. Then you can modify parameters. Right?
This is
So parameter is inside, right? So we can. Alright, good. I hope you enjoy your developing. At least you have your own modeler in your smartphone. You can show it to your parents, right? Right? Well, that was my comment.
our team, should our team submit the final report
by midnight today.
midnight today?
Can we use the PowerPoint is okay, but only small modification. But once again, please write down good work for the next generation. Right? Very nice.